Recent I-CubeX versions added a number of new features. This video is going to show how to make use of some of these features so that one sensor can be used to capture multiple gestures and map these to different MIDI messages. We'll use EditorX, connected to a WiDig via Connect. All settings can be downloaded from the link below. The WiDig must run firmware 8.3 or higher and Connect must be of May 1, 2023 or later. EditorX must be version 8.3 or higher. To generate sound, we'll use Garageband. On Windows you could use LMMS, but there are many other sound synthesis and digital audio workstation software programs. Ableton Live will provide you with many more mapping options. In the first example, we'll explore the MIDI keyboard key concept using note on and key pressure MIDI messages. Connect the touch sensor to the WiDig. It captures contact force. In Garageband, select a sound that can be modulated once it's triggered, like heavy sub-bass. Let's configure input 1 so that it triggers audible output. First, set the sampling interval to 1 millisecond to minimize delay between sound and gesture. To output control data that more closely tracks the force that the user feels, so that it's easier to execute control, pass the touch sensor data through lookup table 0 and apply a bit of smoothing. To capture the touch and release gestures, set the processing to peak and peak end using the processing menu. Increase the threshold value just a bit from 0 so that the sensor value can cross it and trigger output. Set the window field to 3, i.e. compare the current sensor value with the past 3 to see if it has peaked. To capture pressure changes once the sensor is touched, keep continuous selected in the processing menu. Set MIDI message to note on and note to 60. The continuous data after touching the sensor is output as MIDI key pressure messages. For the heavy sub-bass sound, the minimum MIDI output value needs to be increased to prevent the output volume being too low when very lightly touching, so that the modulation afterwards would result in just distortion. Turn the input on. Now each time the touch sensor is touched, a note on message with the loudness correlated to the impact force is triggered, and if the finger is held down, the touch force can be varied to modulate the sound. Upon release, a note off message is output. In the second example, we'll show how to not only capture but also map touch, press and release gestures. In Garageband, select a percussive sound, like a marimba. To capture the touch gesture, set the processing to peak, peak end and constant using the processing menu. Peak will be exchanged for thresh, indicating the processing doesn't search for and output a peak value once the threshold has been passed by the sensor value. Instead, it outputs a constant value, which is set to 127. Increase the threshold value just a bit from 0 so that the sensor value can pass it and trigger output. Set MIDI message to note on and note to 60. In the second input, copy the settings from input 1 but increase the threshold value almost to its max value so that it triggers at a higher force. Set the constant value again to 127. Set the note to 61, to use data that more closely tracks the force the user feels, so that it's easier to apply the right amount of force for the trigger to occur. Pass the touch sensor data through the same lookup table as in example 1. Turn the input on while holding down the Shift key to set it in ghost mode. In the third input, set the processing to peak, peak end and constant using the processing menu. To detect the release instead of the touch gesture, also select invert using the processing menu. Set the constant value again to 127. Set MIDI message also to note on and note to 62. Turn the input on in ghost mode. Now, a note on message is triggered both when the finger lightly touches the sensor, when pressing down and when it is lifted. In the third example, we'll explore the so-called MIDI ribbon controller. Connect a slide sensor to the WiDig. The sensor outputs a value correlated to the position when touched. In Garageband, select the classic electric piano sound. To capture the touch and release gestures, set the processing to peak and constant from the processing menu. Set the constant value to 127. Increase the threshold value just a bit from 0. Set MIDI message to note on and note to 60. Turn the input on. In the second input, keep the continuous setting in the processing menu. Set the MIDI message to pitch bend. To prevent the pitch bend to change upon release when the sensor value drops to 0, use lookup table 1 where the lowest values are set to be skipped so that no output occurs. Turn the input on in ghost mode. Now each touch triggers a note on message with velocity 127 and each release triggers a note on with velocity 0, i.e. a note off message. The touch position determines the pitch of the sound. After touching the sensor, the pitch of the note can still be varied. In the fourth example, we are creating a mini musical instrument by taking the previous example further. In Garageband, keep the classic electric piano sound. We've configured 4 input pairs as in the previous example, each limited to a section of the slide sensor by using lookup tables. Each input uses its own lookup table where the values outside the range are entered as 1024 so that the WiDig skips them. Now each section triggers a different note upon touching, and sliding the finger afterwards changes the pitch and can be used for a vibrato effect. To create a lookup table like used in the last example, click Edit to open the table editor window. Select the table number you want to use and click View. Then click Calculate to generate a linear lookup table. Then set the values to skip to 1024 by dragging the mouse pointer, which is displayed as a cross, just above the green area. You can also manually edit the table by clicking right and then editing the saved file in a text editor. Once the table is edited as needed, click Read to load it into the table editor and then click Store to upload it to the WiDig. Download all the EditorX settings, including the tables, from our website and try it out. See the link below.